Well, another podcast, another couple more key terms. This one is called coterminal angles. Think about this as a spinner. That's the best way to think about it. Look at this. If I have a spinner and it sits right there, and I flick this spinner so it goes around and around, look at this. Every time the spinner goes around, no matter how many times it goes around, if it ends up in the same spot, it's the same thing. Like, honestly, it's only moved that much if you think about it. Okay, sure, it's gone around a billion times, but it actually comes back to the same spot right here. That's what we mean by coterminal. So what is a coterminal angle? Think about this. If this angle here was, let's say, 30 degrees, if I spin all the way around and go back to here, what did I just add to the 30 degrees? Yeah, I added one complete spin, which is 360 degrees. And I can do that as many times as I want. But how about going backwards? Can I go backwards as well? Sure. If I'm here, going backwards means I just subtract 360 degrees. So I'm actually looking at a multiple of 360 degrees. How am I going to indicate a multiple? Simple. I'm going to either add the 360 degrees or subtract the 360 degrees by some kind of multiple, which in this case we're going to call k. Okay, k is the multiple. Oh, okay. What does k mean? A k could be any value of the integers. Oh, so if it's something like 2, be 360 times 2, which would be 720 plus 30 degrees. That's 750 degrees. That would be 750 degrees. Think about it. It's gone around twice, right? 720 times, plus another 30 degrees, 750, and I landed in the same spot again. Or I can go backwards. That would make it an integer, a negative one. So this is the multiplicative factor. That's the amount you're going by, and there's the original angle. Huh, but what if this is radians? Ah, man, everything's got to change, right? No, it doesn't. 30 degrees, you're going to find out, is actually pi over 6. I'll explain where that comes from eventually. You're going to either add or subtract some sort of multiple of, now, not 360 degrees, but remember, what's your distance all the way around? It's 2 pi. So you're going to multiply by some multiple of 2 pi, whether that 2 pi is 1, 2, or 7, or negative 15, whatever the multiple is. Remember, k is an element of the integers. Well, boy, that makes life just so simple. Yeah, that's one of the reasons why. If you look at the number 150 degrees, how did I get from 150 to 510? Surprisingly enough, all I added was 360 degrees. Added 360 degrees again, subtract 360 degrees, subtract another 360 degrees, subtract another 360 degrees. Okay? That'll still get you to the same spot of 150. That's the whole point. So in this particular question then, if you read this, it says determine 2 positive and 2 negative angles that are coterminal. That's simple. Watch. I'm going to take the 200 degrees. I know I haven't surpassed 360, so I'm good, right? I'm going to add 360 to this. By adding 360 to this, I'm going to get 560. There's your first angle. And then I'm going to add another 360 to this. If I add 360 to that, I'm going to get 920 degrees. And I can do that directly in my head. Wow, there's my 2 positive ones. How about the negative ones? Let's go right from 200 again. So now I'm going to go 200. And all I'm going to do is subtract 360. And when I subtract the 360, I get negative 160 degrees. There's our first one. And then again, I'm just going to subtract 360 degrees again. That's going to give me a value of negative 520 degrees. Oh my gotcha, that's so simple. So now I got my 2 positive ones, and I've got my 2 negative degrees. Easy peasy, right? Right. But what happens if the degrees is like B? Look at B for a second. B says it's 465. So I'm already over the 360 degrees, right? Yeah, no kidding. So since I'm over, I'm kind of curious, how much over did I make it? Well, go 465. Let's subtract the 360 from this. If I subtract the 360 from that, that's 5. That cancels. That gives me 105 degrees. I'm actually over 105 degrees. So guess what? I just gave you another positive value, though, didn't I? So why don't we just go and add to this guy? So I know one of my positive values is 105, but why don't I just add another 360 degrees? Now, you don't have to go back. There's nothing saying in the question that you had to go back like I did. But I just wanted to state the obvious, the fact that we're, in fact, over 360 degrees already. But what if I want one more coterminal angle? So take the 465. There it is, 465 degrees. Let's add a 360 to that. If you add a 360 degrees to that, that works out to be 825 degrees. So there's your two positive angles. But look how easy it is to figure out the negative one if I've got this smallest possible coterminal angle. Okay, 105, then I can now subtract the 360. If I want to subtract the 360 from that, I'm going to get minus 225 degrees. And then if I want to do this one more time and subtract 360 from that, I'm going to end up with minus 615 degrees. So there's my two negative degrees. Where is it? There and there, right? And my two positive ones being 105 and 825. Got it? Okay, let's do the same thing, and you'll actually find, surprisingly enough, you'll find the radians easier. I know you're probably saying to yourself, really? Yeah, because it's based on, guess what? It's based on common denominators. Oh my gotcha. That's so easy. First thing I do, whenever I see a radian angle that's expressed as a fraction, I immediately go, okay, how do I express 2 pi as the same style of fraction? It's over 1. The fraction is, of course, then multiply top and bottom by 3, giving me 6 pi over 3. And if you think 6 pi over 3 is just 2 pi, isn't it? So now that I'm in common denominator of 6 pi over 3, all I have to do is remember I can add or subtract to this. Makes it really, really, really easy. Okay, so let's do the first one. Minus 2 pi over 3. Okay, let's add 6 pi over 3 to that. And look, common denominators makes this easy. 4 pi over 3. Okay, there's my first positive radian. Add another 6 pi over 3, and there's my second one, 10 pi over 3. Oh, look at that. There's my two positive angles right there. I think it's easier to do that than it is to deal with degrees, because degrees tend to be such big numbers, right? What if I want to go backwards? Okay, let's go backwards. Let's go backwards from minus 2 pi over 3. Let's go backwards. Subtract 6 pi over 3. Okay, 2 pi minus 6 pi is going to be minus 8 pi over 3. And then do it again. Minus 8 pi over 3. Subtract the 2 pi, which is 6 pi over 3, right? To give you minus 14 pi over 3, right? There. That easy. Okay? Take a look at the next one. 17 pi over 6. So, just like we did before, let me clean this up. Hold on. 17 pi over 6 now is what we're dealing with. Okay? Take your 2 pi. Remember, it's 2 pi over 1. Now make it a factor of 6. So multiply top by 6, bottom by 6. This is going to be 12 pi over 6. There's your additional factor, the one that you're going to add or subtract in multiples. Okay, let's do it. All right, here we go. First things first. I notice that this is 12 pi over 6. So in other words, this guy obviously has gone over. He's gone too far. All right, so let's do the first one. 17 pi over 6. Let's subtract 12 pi over 6 from this guy. And let's find this guy out to be, well, yeah, you're right. It's going to be 5 pi over 6. There's your first positive, right? Now, since we're already at 17 pi over 6, we can add 12 pi over 6 to this. Okay, so 17 pi over 6 added 12 pi over 6 is 29 pi over 6. So there's your two positive values. And this looks like the smallest positive value. Eventually, what you're going to learn in the next podcast is something called principal angles. That's actually the principal angle. But, okay, that's the next podcast. Let's keep on going. Now let's go into the negatives. Okay, I'm going to start with this guy because it tends to be the smallest one. So 5 pi over 6, but now I'm going to subtract, my 12 pi over 6 from this guy. Okay, so minus 12 pi over 6. So I'm going to add a negative, okay? 12 pi over 6, 5 pi over 6, that looks like negative 7 pi over 6 to me, right? Perfect. Let's keep on going, okay? If we subtract again, 12 pi over 6, look what we get. We have minus 19 pi over 6. So all you're basically doing is adding and subtracting multiples of the same thing. It just makes all kinds of sense to me, right? Let's keep on going here. Let's finish this podcast off. Okay, look what this is. In general, there is infinitely many angles that are coterminal, because think of the spinner. The spinner can go round and round in a circle for a long time, right? Infinite, right? For this given angle. So how do we do this? We have to remember, in degrees, we add 360 n's, where n is some sort of value of I. Sure. In radians, we add 2 pi, where n again is some value of I. It always seems to be a multiple of either the degrees or the radians.